Good morning, students. Now I am starting the last chapter, that is semiconductors. If you have any doubt while teaching, write in the chat box and request your friends to join in the class immediately because this is very important chapter. Right? Let us start. And then from the semiconductors, you have total theory, right? It is very easy chapter. From this chapter, you will get the 7 marks. Okay, right. And listen with very carefully, right, starting the class. Semiconductors. What is a semiconductor and how it will works? What is its use? The advanced technology and the computers and some other robotics and everywhere in advanced technology we are using the semiconductor components, right? And we are using the LEDs, we are using the solar cells, and there are so many applications are there, and resistance and some others. We are using the semiconductors in the various fields in advanced technology. Now let us discuss about the semiconductors. Before that, classification of solids based on the electrical properties. I am going to explain the classification of solids based on the electrical properties. And is it clear, students? My voice and picture, right in the chat box. Right. Classification of solids based on electrical properties. Electrical properties means based on the current, right? We have to classify the solids into three types: conductors, insulators, semiconductors. Let us write the differences. Conductor means it allows the current to pass through them. Insulator means not allow the current. And semiconductor means it can its properties. That means partially it will allow the current. Fully it will not allow the current. Okay, and partially it will allow the current, and its properties are lies between the conductor and insulators. Okay, right. And why some material will act as a conductor and some material is insulator, some material is semiconductor? Because of availability of free electrons in every substance is made up of atoms. Okay, every atom is made up of protons, neutrons, and electrons. That means whatever it may be the substance, anything matter, right? It contains the atoms and electrons. But due to the flow of electrons, current will be generates. But why some allow the current and some not allow the current? In every material, electrons are there, and electrons are the charge carriers. And then why current not flows? And electrons which are in the atom, they are not useful for the flow of current. The electrons, if for example this is a nucleus and this is an atom, okay, and if electron is revolving it here like this, and if this electron is inside the atom, then at that moment if the electron is inside the atom, okay, if the electron is inside the atom, if electron is inside the atom, at that moment that electron is bound by the nucleus. It is not allowed to move. That's why that will not flow in the conductor. That is not useful for the current. The electron which is free from the nucleus attraction, that means the free electrons only useful for the flow of current. In some substances free electron availability is there, and some substances free electrons availability is not there. If free electron availability is there, then that is called as the conductor. If the free electron availability is not there, then that is called as insulator, right? And the conductor means free electrons are there. Free electrons only useful for the flow of current, not general electrons. Okay, right. And free electron availability is not there. Electrons are there, but the free electrons are not there. Free electron means electron which escape from the atom, and it is uh, easily moves on the surface of metal, right? And that is the free electron. Okay, and conductors, insulators, semiconductors, that are defined based on the number of charge carriers. Okay, right. The substances have, if you have any doubt you can write in the chat box. Is it clear, students? Okay, Sushmita said that it is clear, right? Okay, and now if you have any doubt write in the chat box. Okay, right. Now, what about the conductor? These substances have the high conductivity. Conductivity is more in the conductors. Low resistivity means resistance. Resistivity means what? Resistance per unit length per unit area is called as resistivity. Resistance per resistivity formula, you know, na? Rho is equal to RA by L. Right? Resistance per unit length per unit area is called as resistivity. Low resistivity. Conductors have low resistance, low resistivity. Right? Insulators is reverse. They have low conductivity and high resistivity. Low conductivity not allows the electrons to pass, right? High resistivity means large resistance is there. These semiconductors are the materials whose resistivity and conductivity lies between the conductors and insulators. Now let us go for the third point. Right, you see here conductors. Third point, you see these conductors have the positive temperature coefficient. What is the meaning of the positive temperature coefficient? Positive temperature coefficient means if temperature is increases along with that, uh, their resistance also increases. That means positive temperature coefficient. About temperature coefficient we discussed in the current electricity chapter. If temperature increases, resistance also increases, then that are the having the positive temperature. And insulators have the negative temperature coefficient. That means if temperature increases, then resistance decreases. And even semiconductors also have the negative temperature coefficient. Negative temperature coefficient means if temperature increases, then what happens? If temperature increases, the resistance decreases. If temperature increases, then resistance decreases. Right? And example for the conductors is copper, aluminum, gold. You know that all the metals, right? Metals are the conductors. And insulators are the rubber, wood are the insulators. They will not allow the current. In rubber also electrons are there, but free electrons are not there. That's why it is an insulator, not allow the current. Right? And germanium, silicon, this germanium, silicon, and cadmium, sulfur, gallium arsenic. These are the example for the semiconductors. Semiconductor means sometimes they will allow the current, sometimes not allow the current. Sometimes it acts as insulator, sometimes it will act as conductor. This is about semiconductor. Right? Is it clear, students? Write in the chat box my topic. Okay. Now it is appearing clearly now. Band theory of solids. What is the band theory of solids? Okay, solids band theory. What is this? Let us discuss about the band theory of solids. For the purpose, you see here in this, what happening if you take the one isolated atom? If you take one isolated atom means what? Just you are feeling that only one atom is there. In that, there are several energy levels is there. You see this diagram. Isolated atom, first one, band theory of solids. I will explain. And this is an isolated atom. It has the uh, one orbit, two orbit, second shell, first shell, second shell, third shell, like that. And 1s, 2s, 2p, 3s, 3p, 3d, like this. These are called as energy levels. These are all energy levels for certain atom. Okay, one orbit is said to be one energy level. Okay, and like this in every orbit, some of the electrons will be there, and some of the uh, they have some energies. This, in case of isolated atoms, the energy levels are isolated. Okay, they are also isolated. And now if you take the solid atom, what happens? If you take the solid atom, in that, atoms are very close. If the atoms are close, then what happens? If the atoms are close, then one atom is influenced with the other atom, right? When one atom is influenced with the other atom, for example, this is an atom, and this is an another atom, and this is an another atom, like this many atoms will be there, and all the atoms are very close to each other. Due to that, what happens? this is one atom and this is another atom. When the atoms are very close to each other, when atoms are very close to each other, the outermost orbits are overlap with each other. Okay, outermost orbit means, for example, this 3p is the outermost orbit, 3s is the outermost orbit, it is considered third shell. These outermost orbits of different atoms are uh, interlock with each other, and they are super, sorry, not interlock, overlap with each other. Due to the overlap of energy levels, we will get some bands, group of energy levels. That group of energy levels is called as the energy band. You see here, for one atom, okay, for one atom, this third orbit is, for example, outermost orbit. And like this, if many atoms are there in the solid, all the atoms are very close, that's why the outermost orbits of one atom are overlap with the other atoms. Due to that, what happens, energy, group of energies here in this outer energy level, this outer energy level, this outer energy level, like this are overlap with each other. Due to the overlapping of the energy levels, we will get some energy band. This is called as the energy band. This is called as the energy band. Okay, if valency orbits are, for valency orbit means what, outermost orbit, outermost orbit is energy level is called as, orbits only called as energy levels. Outermost energy level or outermost orbits, due to the overlapping of outermost orbits, we will get the uh, outermost energy band, that is called as the valency band. This VB means valency band. In valency band, valency electrons are present. Valency electrons present. If some of the energy is given to the valency electron, that valency electron will be escape and it enters into the other outer orbit, and then that is called as conduction band, and that is called as conduction band. Okay, conduction band is the energy band which is above the valency band. Okay, students, are you getting? Write in the chat box if you have doubts. Okay, right. Now you listen it here. Uh, in for a, in case of isolated atom, okay, energy levels are not overlap with each other. But if you take the solid atom, in that what happens? Outermost energy levels, atoms are very close. When atoms are close, one atom is uh, outermost orbit of one atom is overlap with the other atom. Due to the overlapping of many energy levels, we will get the energy band. They are giving this line set here. They are the energy levels of different atoms. They are overlapping with each other. Due to that, this group of energy levels is called as energy band. This is formed due to the overlapping of valence energy levels. Inner level energy levels not overlap with each other. Inner energy levels are not overlap. Why? Because only outers will be interact with each other, inner does not overlap. That's why only valency bands will be overlap, valency energy levels will be overlap, valency orbits overlap, outermost orbits overlap. Due to that, energy band forms, that is called as the valency band or energy band. Okay, I will explain what I wrote here. In solids, atoms are closely packed, right? And solids, atoms are closely packed. Outermost energy levels of all atoms are overlap with each other. Due to that, energy bands forms. What is an energy band? Due to the overlapping of outermost energy levels, band is formed, group is formed, that is called as a valency band. Why they are overlapped? Because in solids, atoms are closely packed. When they are closely packed, their movement automatically. For example, you are in a line, you are in a line, the line is very hectic, and so many members are there at the moment, then all the one member will be fall on the other member, there are overlapping will be occurs, right? And then similarly here also, in solids, atoms are closely packed, means overlapping will occur. Due to that, energy bands forms. The group of energy levels is called as energy band. Group of energy levels is called as energy band. And group of energy levels means, okay, these energy levels will be combined, and that's why energy band forms. These energy bands are two types: valency band and conduction band. What is a valency band? Due to the overlapping of valency energy levels, valency band will be forms. This valency band is due to the overlapping of valency energy levels. In the valency energy levels, valency electrons are present. That means valency band is an energy band which contains the valency electrons. If any electron escape from the valency orbit, then that electron is called as free electron. For example, this is an valency band, and from that valency, when electron is escapes and it enters into some other band, it is free. It is free. This free electron, this free electron useful for the flow of current, and that is entering into some band that is called as the conduction band. These free electron is useful for the flow of current. That's why these free electrons are also called as conduction electrons. What is conduction band? Conduction band is the conduction band is the conduction band is the energy band in which 1 minute I am adjusting this. Conduction band is the energy band which is just above the valency band. You see here the diagram. This is the valency band. This is the valency band, and above the valency band, conduction band is there. Where it is going? Yes, the energy difference. What is the conduction band? Conduction band means what? It is the energy difference. Energy difference. Sorry. Conduction band means it is the energy band which contains the conduction electrons, free electrons, or the band which may be which is above the valency band. You see here, this is the valency band, energy band, okay, and this is the conduction band which is above the valency band. That is called as the conduction band. Okay, how the band forms? You know that due to the overlapping of energy levels, band will be forms. And next one is the forbidden energy gap. What is forbidden energy gap? Forbidden energy gap means it is the energy difference between the lower level of conduction band and higher level of valency band. It is called as the forbidden energy gap. Forbidden energy gap is nothing but energy gap between the conduction and valency band. Here, while taking the energy band, you have to take the this one, this lower part. What is this? This is the lower, okay, level of conduction band. This is what higher level of valency band. Okay, this is lower level of valency band, this is a higher level of valency band. This is the lower level of conduction band, this is a higher level of conduction band. The energy difference, this has some energy, this has some energy, right? For example, this has E1 and this has E2. Every energy level has some energy, and the difference between energy of lower energy level of conduction band to the higher energy level of valency band. In this is the valency band. In this, so many energy levels are there. This is the top one, is the higher, okay, energy level. This is the lower energy level of conduction band. Okay, in conduction band, this is the lower, next this is higher, next this is higher, this is higher, right? Okay, right. Understood? For the silicon energy gap, the gap is how much? 1.1 electron volts. For the germanium, it is 0.72 electron volts, and for the carbon, energy gap is 5.4 electron volts. And based, this is about band theory. How the energy band forms? Write in the chat box how the energy band forms. How the energy band forms. Write in the chat box. Students, do it fast. Next one is the classification of solids based on the band theory. Now, previously, based on electrical properties, we classified the conductors into components. Now, based on the band theory, how we can classify the conductors, how we can classify the solids into conductors, insulators, and semiconductors. Let us see, based on the band theory, we have to explain. Write in the chat box, students, and how energy band will be forms. Okay, how energy band will be forms. I am expecting the question from you. I am expecting the answer from you. Is it appearing, students? Yes or no? Yes, it is appearing. Okay, Aditi gave the answer. Now, What I am asking, how energy band will be formed? That is my question. This is very important point, very important, very important. It is a previous CBSE question. And how you can classify the solids based on the band theory? Okay, write the difference between the conductors, insulators, semiconductors based on the band theory. Based on band theory, we have to classify these components. To see the this first, conductor means in this valency band and conduction band are overlap with each other. In the conductors, valency band and conduction band are overlap with each other. That's why here you see this is the valency band and this is the conduction band. Okay. Twinkle Lagori answered how the energy band forms. Energy band forms by the overlapping of atoms, right? Due to the overlapping of atoms, overlapping of energy levels occurs. Due to the overlapping of energy levels, the bundle of energy levels forms. That bundle of energy levels or the group of energy levels is called as energy band. Now conductors. The valency band and conduction band are overlap with each other. You see here, and when they will overlap with each other, all the electrons which are present in the valency band, they are also present in the conduction band. Because what happening, these two are overlap with each other, that's when the plenty of electrons or free electrons are there. All the valency electrons also they will be in the conduction band. They are useful for the flow of current. That's why this is conductor. In conductor, plenty of free electrons availability is there because of valency band is overlapped with the conduction band. In the valency band, valence electrons present. And next, conductors, forbidden energy gap is zero. Energy gap between the valency band and conduction band is zero. Why? Because in conductors, valency band and conduction band are overlap with each other. That's why energy gap is zero. Example for the conductors is aluminum and gold. Their resistivity and conductivity range they gave, okay, 10 to the power of minus 8 to 10 to the power of minus 2. Conductivity is the 10 to the power of 8 to 10 to the power of 2. Its 10 to the power of resistivity unit is ohm meter. Conductivity unit is Siemens per meter. Conductivity actually it is the reciprocal of resistivity. Reciprocal of resistivity. This is about conductors. And if you go for the insulators, the valency band and conduction band separated by the large gap. There's a large gap is there between the valency band and conduction band. In valency band, there are so many electrons are available, but then we are unable to provide the energy to jump the electron from valency band to the conduction band. To jump the electron from valency band to conduction band, we have to supply the energy, but we are not have sufficient. We are unable to provide that much energy to jump the electrons into the conduction band. The electrons are present in the insulators, but they will not allow the current because electrons are available, but free electrons are not there. Free electrons were there according to band theory. The free electrons should be present in the conduction band. From where the free electrons will come from where the free electrons comes into the conduction band? From valency band, right? If sufficient energy is given to the electrons which are present in the valency band, then they will jump to the conduction band. They will jump to the conduction band. And if any electron, if it is jumped to the conduction band, then what happens? That electron useful for the flow of current. But here there is a large gap between the valency band and conduction band. That's why no electron will jump to the valency band. Here conduction band is the empty. Conduction band is empty. That's why free electrons available is not there. Conduction electron, due to the unavailability of the free electrons, then no current. Okay. Next, how much energy gap will be there? The energy gap here it is greater than 3 electron volts. Greater than 3 electron volts. Forbidden energy gap is greater than 3 electron volts. And example for this is rubber wood. Okay. And resistivity is the 10 to the power of minus 5 to 10 to the power of minus 6. Okay. And that is its its conductivity is 10 to the power of 5 to 10 to the power of 6. And semiconductors is the valency band and conduction band separated by the small gap. Okay, that is energy gap is less than 3 electron volts. In the conductors, no energy gap. no gap between the valency band and conduction band because they are overlapped with each other. All the electrons which are present in the valency orbit or the valency energy level and valency band, they are also present in the conduction band. That conduction electrons are useful for the flow of current. That's why they will act as conductor. But here the valency band and conduction band separated with a small gap, that energy gap is less than 3 electron volts. Then if small little bit energy if you will give, right, for example at room temperature also at 0 Kelvin, for example at 0 Kelvin conduction band is empty, no energy to jump the electrons from valency band to conduction band. Then conduction band is empty. At 0 Kelvin temperature the semiconductor will act as insulator because no electron in the conduction band. But at room temperature also little heat energy will be there. By gaining that little heat energy, the sum of the valence electrons will jump to the conduction band. Then at room temperature also this semiconductor will act as a conductor. That means semiconductor sometimes act as conductor, semiconductor sometimes act as insulator. That means at 0 Kelvin semiconductor is the insulator, at room temperature a semiconductor is the conductor. That means semiconductor conductivity is lies between the conductors and insulators. The energy gap is less than 3 electron volts. And example is germanium, silicon, gallium arsenide, cadmium, sulfur. Okay, and the resistivity is 10 to the power of 11 to 19 and conductivity is 10 to the power of minus 11 to minus 19. Okay, these are the differences between the conductors and insulators and semiconductors based on the band theory. Based on electrical properties, first one we discussed. Based on the band theory is very important. Okay, right. Is it clear, students? Clear now? Next we are going to discuss about the semiconductors. Okay, you listen very carefully. Right. Semiconductors. Semiconductors classified into two types. What are they? Semiconductors classified into two types. What are they? That are the first one is the semiconductors classified into two types. The first one is the intrinsic semiconductor and the second one is the extrinsic semiconductor. Semiconductors are classified into two types: intrinsic semiconductor and extrinsic semiconductor. What is an intrinsic semiconductor and what is an extrinsic semiconductor? Listen very carefully. It was very interesting. Okay, it was very interesting. And semiconductors are classified into two types: intrinsic and extrinsic semiconductor. What is an intrinsic semiconductor? Pure form of semiconductor is called as intrinsic semiconductor. Pure form means what? Pure form means, okay, there is no doping and there is no impurities. Pure form of semiconductor is called as intrinsic semiconductor. Right? Semiconductors are classified into two types: intrinsic and extrinsic. Intrinsic semiconductor means pure form of semiconductor, that is called as intrinsic semiconductor. And the intrinsic semiconductors example is germanium and silicon. Germanium and silicon. You see here, germanium and silicon. Can anyone write the valency electrons? How many valency electrons present in germanium or silicon? Will you tell? You see here, intrinsic semiconductor is the pure form of semiconductor, that is called as intrinsic semiconductor. And example is germanium and silicon. Germanium is the tetravalent. Tetravalent means what? Four valency electron present. For example, if you take one germanium atom and it consists four valency electrons, germanium or silicon, they are the tetravalent elements. Okay, and they are the example for the semiconductors. And then these are the tetravalent and the four valency electrons of one germanium atom. If you will go for the germanium, some metal, germanium slab, it has so many germanium atoms, and then one germanium atom has the four valence electrons and they will forms the four covalent bands with the, okay, good twinkle, and four germanium atoms forms the four covalent bonds with the neighboring germanium atoms. See here, every germanium has four valence electrons. Every germanium has four valence electrons, and one germanium atom, okay, forms the four covalent. This is one covalent bond, 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 sharing of electrons. Okay, like this, the four, each germanium atom forms the four covalent bonds with the four neighboring germanium atoms. You see here, right, like this. When they will form like this, at the moment they will get the stability. And now there is no free electron, all these valence electrons also in the bond. Okay, when the valence electron by gaining energy, if it jumps to the conduction band, that is the electron which are in the conduction band are said to be free electrons. But when the electrons are present, due to that, again it is not responding. I right now it is responding. You see here, this one has the four valence electrons. Okay, now it is no problem. Intrinsic semiconductor means pure form of semiconductor, that is called as intrinsic semiconductor. uh, all are in the covalent bond. Now what happens by gaining little heat energy, the covalent bonds are the weak bonds, yet even at room temperature also this electron may be jumps, and electrons may be jumped to the conduction band. But electron will be escape from the bond. At the moment here, there is a vacancy is created for the bond. Okay, and the vacancy is denoted with the circle. That circle is called as the hole. Circle is called as the hole. Hole means vacancy for electron. Vacancy for electron. Vacancy is created at here. That vacancy for electron is called as hole. Okay, and dot indicates the electron. Dot indicates electron. Now you see here, if already previously here electron is there, then that electron escape from the bond by gaining the heat energy or some other energy. And when the electron escape from the bond, what happens here? Vacancy is created. That vacancy is called as hole. Okay, hole. And this is electron is the free electron. This electron is the free electron. Where it will goes from the bond, right? This, when the electron is in the valency band, it is in the bond. Okay, when it is escape, when the electron, one electron escape from here to here, and electron become free, and this electron is said to be free electron, right? The electron jump to the conduction band, it is called as a free electron. And when the vacancy is created in the valency band, that is called as hole. That is called as hole. Like this, in the valency band, vacancies are created and the holes are created. When, for example, here four valency electrons jump to the conduction band, then the four vacancies are created in the valency band. Then that four vacancies are called as the four holes. That means holes are present in the valency band and electrons are present in the conduction band. And how many holes are present in the valency band, and that many electrons are present in the conduction band, because how many electrons jumps from valency band to conduction band, that many holes are generated in this. Is it clear, students? Is it clear, students? I am facing a lot of problem with this tab. Why it is not working? I don't know. Is it clear, students? Okay, Puneet. Twinkle gave the reply. Good. Now let us go for the intrinsic semiconductor is completed. Intrinsic semiconductor means where is the cursor? You see here intrinsic semiconductor, there are the four valency electrons are there. It is not responding properly. I will close and again the problem came, students. I don't know what is this, why it is going on. Actually, I want to teach excellently this chapter because I like this chapter. Okay, in the physics, I like the semiconductors. I want to teach very nicely, but due to this technical problem, uh, I am feeling sad. I am feeling sad with this technical problem.